Hey guys, and welcome to a new video in this computer vision tutorial. In this video we're going to talk about object detection and specifically Haar Cascade Classifiers. We're going to see how we can set up a classifier with the Haar Cascades, and then we're going to talk about like what object detection is and how we can apply it in OpenCV, and then actually like apply some algorithms and some classifiers that can detect different kind of objects. It could be like a human or something else like a spoon or some dishes and stuff like that. Like we can train our Haar Cascade classifier on an arbitrary object that we want to detect, or we can even do object recognition with Haar Cascade Classifier as well. So let's first see an example here what we can do with object detection. So this is a video showing what object detection can do, where right now an algorithm is running that is detecting persons and a lot of different kind of objects in the crowd here. So we can see that it both detects like a lot of persons and some stop signs and backpacks and stuff like that. Like this is a more complex object detection algorithm, and we're going to focus more on a more simple one in this case, where we're going to detect some different kind of objects. So let's jump into it and see how it works. So first of all, let's start with talking about like what object detection is, or like trying to classify some different kind of objects in images or also in video frames. So what is object detection really? Like when we're detecting objects in an image, we're trying to like detect a specific object or a lot of different kind of objects in an image. If you're doing like multiple classifications or multiple object detections in one image or in a video frame. So object detection is that when we're detecting some objects that we have like trained our model on or our classifier on. So how can we detect these objects here in the image? And one approach is the Haar Cascade Classifier that we're going to talk about in this video here as well. And there's also like the deep learning approach, which I'm going to make a tutorial on later on. Remember to hit the subscribe button and also like this video if you like the content and you want more in future. It really helps out the YouTube channel and me in a massive way. So I'm really thankful for that and that you're supporting me doing this. So in this video, we're going to talk about the Haar Cascade Classifier and focus on that, which is more like a basic and simple object detector. So the Haar Cascade like has some different kind of features that is running over the images and trying to like try to match these features here. So we can like, for example, detect eyes or faces because we have trained our model to detect these different kind of features that we have fed images to the training set, or like that we have trained our model on. So some of the applications here of object detection is we can do it for a lot of different kind of objects. And if we're doing, for example, object tracking, we want to track an object in an image or track some persons or vehicles that is driving around, then we can use object detection to do that. And also in security systems, if we want to see if something is wrong or if someone is inside where it shouldn't be, or stuff like that. And we can also use it in autonomous vehicles, which is a really nice approach, and also like it really depends a lot on object detection when we're talking about autonomous vehicles, as we can see down here on the image, where you can see that it can detect like different types of vehicles like cars and minivans, and also like pedestrians and some other different kind of objects in an image. So it can be used for a lot of different kind of things, and it's a really used thing in modern like artificial intelligence and deep learning with object detection, deep learning with neural networks, and then computer vision combined together. So we can see that here we have a camera where computer vision and deep learning is used together to like make this kind of view here that can be used to drive vehicles, so it will be autonomous. So we'll jump in here and talk about the Haar Classifier and get an overview of what it is and how it works, and also like how we can use it in computer vision and OpenCV. So first of all, we have these different kind of Haar features in the images, which is like when we're doing efficient calculations. So when we have an image, we're trying to have some different kind of features that we're running over our image, and then we're trying to match these features here and see if they match. And if they match, like we can find different kind of objects that we train our model on. So when we're training our model, we train it with images where we both need positive and negative samples of what we want to detect or recognize. So in this case, with the persons down here, like if we want to train it to detect persons, we need to give our classifier, when we're training it, we need to give them a lot of images with people on it, and we also need to give it a lot of pictures where there's no people on it, so we can like find the differences and like find the different kind of features and match those features, so it knows that okay, these features match in this image here because because it's like in the training set, and then we know that a face is in the image, and we also know where in the image it is because we're matching these features when we're doing the Haar Cascade Classifier. So we select the features during training to create like the strong classifiers, and when we're talking about classifiers, we have a weak and strong classifiers. And when we have these weak classifiers here, it could be like for detecting like certain objects or like some features for a weak classifier. And then when we combine all those weak classifiers and we want to like detect faces, like when we're detecting faces, it could be like some weak classifiers of that is combined, like detecting the eyes and the ears and mouth and also nose, and those will be weak classifiers, and then we can combine them together, and then it will be a strong classifier, and it will be more certain for face detection and all the different kind of objects that we have trained our model to classify or like detect. So AdaBoost is to make it like more efficient and having less features, because if we're not using some kind of optimization, like we will just have a lot of different kind of calculations, and it will not really be time efficient. So we're going to talk about this AdaBoost a lot more in this video, because it's really good for when we're training and also when we're like using our Haar Cascade Classifier. So when we're going to talk about these different kind of features that we're running over in our Haar Classifier, then each feature is a single value obtained by subtracting the sum of pixels under the white rectangle from the sum of the pixels under the black rectangle. So down here we can see like these different kind of like kernels or features that we can run over our image, as we can see to the right here. Then we'll have a face here, and then if we try to recognize or like detect the face here, like we have these different kind of features that we're running over the image, and then we can see that we get a feature here, like for example this kernel or like filter here would be good to use to detect the eyes of a person in an image, and also like this filter or feature here would be good for detecting the nose, for example. And then we have these different kind of features here that can be combined together, and then as I already said, like each feature in an image is a single value obtained by subtracting the pixels under the white rectangle, which is the white rectangles down here at these kernels here that we're applying to our image, and then we subtract those from the sum of the pixels under the black rectangle, which is the black rectangles like here, and also like over here in the example when we're detecting persons here. So how can we select the best features in our image? Because if we're trying to detect faces, like we don't really care about a lot of other different kind of features that is good for detecting other different kind of objects when we're only focusing on detecting persons or like people in an image. So we can use this AdaBoost, as I already talked about, which just finds the best threshold that classifies the faces to positive and negative values if we're trying to detect faces in an image. Then we can use this AdaBoost here, and it's also like used to reduce the features, so we will be more time efficient with the calculations, like more efficient with our calculations, because we have to do less of them. So we will both be faster and also like a better approach when we're using this AdaBoost here compared to if we didn't do any optimization at all. So when we're going to train our Haar Cascade here, then it is possible to train it on whatever you want to detect or recognize. You just need a lot of both positive and negative samples. So if you want to like for example like detect a cat, then you will need a lot of like thousands of images of cats, and then you will need like thousands or like more than also like positive images or like samples of images where there's no cats in the image, and then it will train on those on that data set, and it will try to like find the best features and try to like find the features that matches a cat. And then when we give our Haar Cascade model a new image, then it can detect if there's a cat or not a cat in the image, because it had learned the features from training. So it's trying to find the best features to use at each stage of training. So the training is divided into different kind of stages, and then we have features that is good for some stages, and then we use this AdaBoost here to optimize the number of features, and then we're only using the best features in each stage. So we might start off with a lot of different kind of features, and then we just like take away a lot of the features that we don't want to use in this example and for the application that we're going to train on. And then the longer we come in the stages, like the more stages we're in, the less features there are, and the more efficient our calculations and also like our time will be. So when we combine all of this here, we have this Haar Cascade Classifier that we can actually like use to detect objects. So we use a cascade of classifiers because, as I talked about, we have these weak classifiers that we can like cascade together. So when we're talking about cascade of classifiers, we have these features here that are grouped into different stages and applied one by one. And then the window, or like the feature that passes all the stages, is a phase region. So as I talked about, we get less and less features because we were using this optimization and add a boost here. So if one feature or like a couple of features passes all the stages that we've been through, then we know that it's a really good feature and it will be a phase region in the case of where we're going to like train a Haar Cascade Classifier to detect phases. And we also have this weak and strong classifiers here, where the strong classifier is just a combination of the weak classifiers. And when we have a strong classifier, like and we have combined a lot of different kind of weak classifiers to detect some certain like features in an image, or like some certain objects in an image, then we can actually like use it for recognizing objects. So we're not only like detecting objects, but we're actually like recognizing objects. So how can we improve the detections and computation time? As I already talked about, well, like we can cascade the strong classifiers, and at each state we can accept or reject features, so we get less and less features, so our computation time will be better. And this is like all come down to this add a boost optimization here for the Haar Cascade Classifier. So when we're talking about recognition here with Haar, like we can also do recognition. So first of all, we need to define like what recognition is and compare like what is the difference between detection and recognition. And when we're detecting a phase in an image, for example, we're just detecting it, we don't know anything about the phase, and it could be like an arbitrary phase. But when we're recognizing something in an image, like it has to be the exact same thing. So if we're going to recognize a person, like it do matter what person it is. So we can like detect, for example, a celebrity or something like that. And then if another person came into the image, then it wouldn't detect it because it has recognized that it is this certain person, or like this person here, and other persons that are in the image is not that person. So that is the difference between detection and recognition, and it's like a really good thing to know like the difference between them. So when we're doing face recognition here with the Haar Cascade Classifier, we need a lot of data for like both the positive and negative samples, and also like a lot of features to tell differences between if we're just recognizing or if we're just detecting people, because we need more detail and a lot more features to do recognition than only doing detection. So again, we just need a lot of different kind of samples of that person that we want to recognize in our image, and even more if we just wanted to detect a person or in an image instead of recognizing. So to do Haar Cascade Classifier here in OpenCV and actually like apply this and do some object detection in OpenCV, there's some pre-trained classifiers that we can actually like use, and they all come with the OpenCV library. So all of these pre-trained classifiers here are already like optimized and they're really robust. So they're really good to use, and also kind of like the best to use if possible, and if they fit to your application. But it's also possible to make your own Haar Cascade Classifier if you have a lot of different kind of images of the object that you want to detect or the object you want to recognize, and then you can do like the optimization by yourself, and then you can create your own object detector and detect whatever you want. So over here to the right, we have a list of the already pre-trained classifiers that we can just load into OpenCV in C++ or in Python, and then we can just use this Haar Cascade Classifier here to do the actual object detection in OpenCV. So another approach here, and a short introduction to another tutorial that I'm going to do, is deep learning, which I showed you in the start of the video and also in the autonomous vehicles, where we're working with neural networks to like learn these kind of features instead of using this Haar Cascade approach. So neural networks is just like for object detection as well, and also like for object recognition, but they're more efficient and both computation wise and also like for a lot of other different kind of purposes. So deep learning tutorial in the near future, I'm going to do that, where we're going to like first talk about like how neural network works and the elements of a neural network, and then we're going to use the Python modules like TensorFlow or PyTorch to actually like implement neural networks in code, and also apply some training to the neural networks, and then try to do some predictions with idea like objects and some other different kind of stuff. And if you guys are interested in it, like we can code a neural network and its element like from scratch, where we have some different kind of methods and some different kind of optimizers and functions that we can implement ourselves from scratch in either C++ or Python. So leave a comment down under if you're interested in this and you want me to do a tutorial where we're also going to build a neural network from scratch and not only using these Python modules where we just have like a model that we can train on and do our implementation. So we're going to see how to train a neural network and how it can be combined with computer vision, because like deep learning and computer vision is like really good together, and they're like really efficient, and they can be used for a lot of different kind of like applications and also more practical examples. So many modern applications like can be solved by using deep learning and computer vision together. So they are really strong together, and it's really good to know. And that's also why I'm going to do an deep learning and neural network tutorial, and like try to combine it with this computer vision tutorial to give you this like overview, and also like tell you guys how to actually like use this in modern application for like autonomous vehicles and a lot of other different kind of stuff. So we're now doing the Visual Studio here, and I'm going to show an example of how we can load in already pre-trained Haar Cascade Classifier, and then we can open up a video frame and actually like do face detection in OpenCV with C++. So first of all, here we're going to include the OpenCV library here, and then we have a function here that actually like does the face detection. So as a parameter, it just takes like the frame that we want to detect the faces in. And then first of all here we're going to convert that frame that we get into our function here, and we convert that to grayscale, because if we don't grayscale it, we need to do the calculations on 3 channels instead of only 1 channel. So we'll be more efficient, and it will also give us a better result if we just do the face detection on a grayscale image, and it won't really do anything to the algorithm, and it will just improve the time and computation time. And then first of all here we have a vector here that's just going to contain rectangles, and the rectangles will be the faces that we're going to detect in the image. And then we have this detect multiscale here, which is the built-in function. Which is a built-in function in OpenCV to actually like do and apply the Haar Cascade Classifier that we have loaded in, and like the pre-trained classifier that we already load into this face cascade here. And then it just takes the grayscale image here, and then it outputs the output here to the faces vector here, which is rectangles. And then down here we just have a for loop here that runs through all like the faces that were detected in the image. And then we just draw this ellipse here in the image around the face that we have detected. So this is just like how we can set up like we want to draw it on the colored image, and we have like a center where the face is detected, and we also like have the size of the faces and like the radius and something like that, and the color. So this is just a for loop to like draw all the faces that we're detecting in our image when we're running our object detection or like our face detection. And then we're just going to show the image here that we have done the object detection on, like or face detection. So this is the function that actually like does the face detection, which just takes in this frame here. And then down here in the main function, we first of all have this face classifier here, which we're going to load in. This is the Haar Cascade frontal face alternative 2. So this is an optimized facial detector. We can also use the default one up here, but it will give a lot more false positives, and this one down here will do its job, and it's the most optimized one as lately. So first of all here we're going to check if we could not load the classifier, and it'll just like see out this error here and return -1. And else we're just going to open up the video capture here. So we're going to open up my webcam here, the 0th index here of the webcam. So we're going to load in this video stream here from the camera, and then first of all we're going to check if we could not open the image, or and an error occurred. And if it opened correctly, it will just go down here, and we have this frame here, and then we will have a while loop here where we're just running our face detection all the time and our frame all the time, as long as we're reading a frame from the camera. So as long as we're getting an input from our camera in the computer, we're going to run in this while loop here, and then apply the face detection down here with this function here that we created up top here. So first of all, we're just going to check if the frame is empty, and if it's empty, we just see out an error, and then break out the while loop. And also we just apply this face detection with the Haar Cascade Classifier that we have loaded in up here. and then we can just say that we want to terminate the program if we hit Q. So let's run this program here and see what the output gives us. So we're gonna run the program here, and we can see that we're actually like doing the face detection now. And if I move around, it will still like detect my faces here. Like it's a bit like sloppy here, and sometimes it also detects some false positives. But this is the most optimized pre-trained model there's yet. So if I move around here, like we can see that it actually like detects my face even though I'm moving around here. And also like if I tilt my head a bit to the sides here, but sometimes we will get some false positives. But this is like kind of a good face detector, and it can be used for some simple applications, and also like just to get started with face and object detection. And then you can also improve in that and like go over to more complex models within deep learning and stuff like that. So we're now seeing how we can detect faces in images and also like in a live video frame. It was a bit like sloppy, and also like we got some false positives, and it was really laggy. So there could be some optimization done and stuff like that. But it's not really the most optimal one, but it's a really simple one and fast to set up, and it could be good for some different kind of simple applications. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification on the video, and also like this video if you like the content and you want more in the future. I'm currently also doing an algorithm data structure tutorial in C++, and also an artificial intelligence tutorial where we're currently talking about reinforcement learning and how we can apply Q-laning to have an agent interacting with the environment, getting some rewards, and then training that agent to do some different kind of applications that we want it to do. So if you're interested in one of those, I'll link to one of them up here, or else I'm just seeing you next video, guys. Bye for now.